ground source, water source, air to air, indeed, what you might refer to as air conditioning. And we have a much broader view on the electrification of heat generally. So whilst we were a heat pump brand, and most of the work that we get involved with does feature a heat pump of some sort, electrification, as opposed to burning fossil fuels, is where we're really at. So we do have a slightly broader remit. We cover the whole sector from domestic right up to very large commercial systems, supply chain, end users, installers, and our dominant function was to lobby government for policy that was friendly to electrification. But we have been drawn into all sorts of other areas, including providing education and information to community groups such as yours. And we're carrying out this sort of engagement at the rate of about one a week at the moment. So very pleased to be here and look forward to the evening. Thank you.
Great.
I'll go next. Evening, everyone. I'm Richard Hauxwell-Baldwin. Excuse me. I was at the previous meeting, so some of you may have been there and recognise me from that. I'm the Research and Campaigns Manager at the MCS Charitable Foundation. As a charity, we have a very broad and challenging remit, which is to decarbonise homes, heat and energy. So it's a very, very broad remit, and my role within that is supporting our advocacy work, our campaigning work with evidence-based research to support our position. Well, first off, to form a position and then to support it. My work covers everything from the green skills agenda. The government has a target of 600,000 heat pump installations a year by 2028. Well, that sounds great, but how are you going to do it if you don't have installers? So a large part of my work is around recruitment and engagement in the green skills sector. I also do work around what we term mass scale retrofit. So there's a recognition that the 29 million homes in the UK are not fit for the future. We need to future-proof them. How do we do that? Well, we need to retrofit them with insulation, double glazing, heat pumps, decarbonise heat, etc. And so as much as my work does focus on advocating for true decarbonisation options, there's a significant chunk of it that is also taken up with campaigning against false solutions. So I'm here as a heat pump expert, but last week I was here as a hydrogen and CCS expert, which I also can wear that hat. We see green hydrogen as having a place in a net zero future, but that place is not in the home. So just to be very clear from the outset, we are not anti-hydrogen. It's a very powerful and useful decarbonisation tool in sectors for which there is no alternative. And that would be things like heavy industry, possibly aviation. But there are commercially available, truly zero carbon options that are available now and are deployed in their millions around the world, delivering efficient, low carbon heating to happy users who are warm. In the interest of declaration, the MCS bit stands for the Microgeneration Certification Scheme. That's the standards organisation that designs and enforces is probably too strong a word, but applies standards around which small-scale renewables like heat pumps and solar PV have to be installed to. As a charitable foundation, we are the sole shareholder of the MCS service company, and that's where our funding comes from. So I have been accused by certain people, some of whom you might be familiar with from other engagements with hydrogen, of having vested interests, to which my response is we make no secret about where our funding comes from, but all of our positions are based on research. They're heavily researched, they're heavily referenced. If any of you've read my hydrogen briefing note on my CCS briefing note, you'll see there's, it's not me making this stuff up. I don't have shareholders to appease. I don't have targets to reach in that sense. I'm here because I truly believe that a heat pump is the best decarbonisation option for millions of homes in the UK. And I say that not just from a professional perspective, I say it from a personal perspective because I have one. I've got a heat pump that's gently whirring away in this cold Norfolk night, and my house is toasty warm, and I'm happy to answer any and all questions about the practicalities and the realities of living with a heat pump. And thank you very much for having me.
Brilliant.
That's you, Julian. Julian,
is it me next? Is it? Yeah, I'm nervous a bit. So my name is Julian Hodgson. I work for MCS. I am a heating engineer by trade, and I'm not going to throw words like expert around, but I do know quite a bit about keeping people warm in their homes, and I know a little bit about converting gas boiler systems to heat pumps as well, and the requirements around that. I'm here primarily to answer anyone's questions, mainly on a technical basis around those areas, and as Richard's wingman, in case anything comes his way that he can't field, he's going to bat my way, I think is the idea. But yeah, I think
Julian is my expert.
Yeah, I'm not sure about the E word, but I think between Bean, myself, and Richard, we've got all bases covered here.
I think so.
Yeah, I've been involved in the plumbing and heating industry since I started as an apprentice with my dad for my sins at the age of 16. My dad was ex-BG, and I've been installing or working within the heating industry ever since. I've installed boilers, obviously boilers all over the place, numerous heat pumps as well, gone from gas boiler to heat pump systems. And my next project here at home, as Richard has recently done, I will be converting to a heat pump from an oil-fired fossil fuel boiler. As soon as I possibly can, I'll be doing that. But yeah, so that's me.
Brilliant. Thank you, everyone. So I'll, unless anyone's got anything else they want to ask or say, I think it'd be good just to get stuck straight into it of an overview of a heat pump and a brief difference between the air and the ground heat pump, just purposefully because I think the information would be useful to have, but just to make it clear that I think there's a couple of chats in the background. Yes, residents have been offered the option of a heat pump as an alternative, but an air source heat pump, not a ground source one anyway, but just that everyone's clear on the difference and what it is. So who's taking that question?
Bean.
Okay.
Yeah, it probably makes sense for you to kick off, Kate, and then I'll let the others come in as and when it's appropriate. So the first thing I would say to you is that heat pumps it's not a scary new technology.
Nope.
You already have heat pumps. All of you own heat pumps. All of you probably got several. So you have a fridge, it's a heat pump. You've got a deep freeze, it's a heat pump. You might have air conditioning in your car, it's a heat pump. You might have a heat pump tumble dryer by now. You may have a coffee machine. These are all heat pumps. Okay, so the point of this is that this is not a scary new technology. We are just applying it in the UK in a way which is only now beginning to rise to prominence. I started installing heat pumps in the UK back in 2008. At that point, so I was an installer for 8 years. At that point, the market was primarily displacing oil in large rural properties. And we went through a couple of oil price shocks. So anybody who's off the gas main would recognize that. I suspect that you're all here because you're all on the gas grid, which is why you're potentially involved in this project. So that's the reassurance. You've all got heat pumps, nothing to be frightened of. The actual technology itself, in terms of difference between air and ground, and we should include water, although I don't want to confuse the picture too much. The device itself is actually common to all of those. All we are changing is the source of the energy. So in an air source, and we should probably say air to water device, we are sourcing our energy from ambient air, so the air that's around the outside of your house, and we are using it to provide water into your existing emitters, radiators, underfloor heating, and into your existing hot water cylinder. So that's air to water. What we routinely refer to as air conditioning in the UK is actually an air-to-air heat pump. So same technology, you're taking energy from ambient air and you're using it to put warm air into the building. Now in the UK, we're quite snobbish about the way we deliver heat. In our homes, we tend to want it to be passive. So that's radiators, underfloor heating. So the heat, the heat just it is passively dispersed around the building. We tend to think that blown air, air-to-air units, is for offices and shops and what have you, which is where it predominantly gets used. And in fact, most hotel rooms, when you go in through the door, you're in a small lobby, the ceiling's quite low, you walk out into the room, the ceiling raises. If you turn around and look behind you on the facing wall, you'll usually see a grill. Behind that grill is a fan coil, and that's driven by a heat pump. So actually, most of you are probably familiar with heat pump warmth without realizing it. So air source, we're taking energy from the air. Ground source, we're taking it from the ground. And if there were bodies of water or moving water, we could equally take energy from water. With ground source, we can, if we have enough space, lay the pipe work that we use to collect the energy in a horizontal format. In most relatively tight urban environments, suburban environments where gardens are not that large, we would be drilling. And when we're drilling boreholes, the borehole diameter is only about 185 millimeters or so, so about 8 to 10 inches. So relatively small, but they're pretty deep. Average drilling depths in the UK, the depth does depend upon the geology, but average depth of drilling in the UK for ground source is around about 150 meters, so 450 feet. So they're relatively deep. But the other thing to point out is that there is energy, thermal energy in air down to minus 273 degrees. So air source heat pumps will function quite happily at the sort of winter temperatures that we get in the UK. In Norway, something like 90% of dwellings are heated by heat pumps. And interestingly, they have a very high density of air-to-air heat pumps. France and Italy have also seen significant growth in the last few years in air-to-air heat pumps. And I expect that to happen here. I think that we will start to get to grips with having, blown air as our medium for heating our homes, and we'll have air-to-air because it's actually significantly cheaper to install. However, if you've got a wet system already, so you've got radiators, you've got underfloor heating, it makes sense to use to make use of them. So the reason why ground source is attractive is that the ground temperature is much more stable. Of course, it doesn't fluctuate as much as the air temperature varies. And so you tend to get a better efficiency in the winter from ground source because the ground is usually warmer than the air. The other impact is that air source heat pumps have to deal with what we call defrosting. So we spend quite a bit of our heating time with the air temperature between 0 and 5 degrees. It doesn't go below 0 that much here in the UK in terms of hours out of the total heating season. And once you get above 5 degrees, the air temperature tends to rise quite quickly. So we expend a lot of our energy between 0 and 5 degrees. At that temperature, the air is usually relatively humid. And the humidity has to go somewhere when we reduce the temperature of the air when we put it through an air source heat pump machine. And so it tends to frost up an air source machine. The sensors in the device will detect when the evaporator, that's the heat exchanger, so that's the bit you look at that looks a bit like an air conditioning unit on the outside of the house. When that is frosted to the extent that it's less efficient in harvesting energy, it will turn into defrost mode. And at that point, the device is heating itself rather than heating your home. Now, it doesn't mean that you don't get warmth in your house. There are all sorts of mechanisms that mean that your house, and it's only a very short period of time, but what it does do is it impacts on the annual efficiency. And it's one of the reasons why in the UK, comparing like for like quality, air source is fundamentally less efficient than ground source. Doesn't make it bad or worse, but it's a fact of physics. Okay, so it's just something that you need to understand. It's an important thing to understand. Ground source obviously much more expensive to install. We're usually looking at about twice the cost or thereabouts, depending on lots of factors. What is needed in the home to make it effective? So the very crude answer is nothing, because whilst I completely sympathise with and support an approach that says fabric first, and you probably have heard this terminology where you try and improve the fabric of a building, homes in this instance, before you change the heating system. Improving the fabric is not a requirement for a successful heat pump deployment. People talk about hard to treat homes, listed buildings and what have you. Bath Abbey, which is about as leaky and listed as you can get, is now entirely heated by a water source heat pump. The National Trust is routinely now installing heat pumps rather than biomass. They have stopped installing biomass because their members don't like burning trees. So it's not a requirement to insulate heavily. However, all heating technologies benefit from better insulated buildings. And it's really, yes, thank you, Richard. That is Bath Abbey.
Can I just come in quickly, Bean? Can I just come in on that point and make a specific relevant point to the trial residents? I know that some of you have had home assessments, and as soon as you mention the word heat pump, the assessor goes, "Oh no, your property's not suitable." Well, that's just simply not true. I mean, as Bean will allude to, but it's really important to recognise. Yes, there are certain other things that you might need to do to make it more efficient, but in and of itself, pretty much any house in the country you can put a heat pump on. And so when those assessors who are coming to assess you for hydrogen say no, you can't have a heat pump, that's factually incorrect. So just sorry, Bean.
Yeah, no, you're right, and that's good clarification. I was sort of saying the same thing, but not quite as clearly as that. And in fact, government BEIS ran what's called the heat pump demonstrator program, starting 2 years ago, under which they installed nearly 750 heat pumps, a third in Kent, third up around Newcastle, and a third up in Scotland. They audited, I think, several thousand, I can't remember how many, but several thousand houses to find the 750. The auditors couldn't find a dwelling that they couldn't put a heat pump into. Okay, so really important to recognise that. Now, boilers, gas, you're all on mains gas at the moment. Condensing boilers, and most of you, I suspect, have condensing boilers by now. They were mandated for in 2005. Condensing boilers are low flow temperature devices. They are actually, they should be installed with a flow temperature of 55 degrees or less. I don't think you need to worry too much about the actual temperature, but the point is that for a condensing boiler to operate in condensing mode, it needs to have a return temperature of 56 degrees. And the only way to guarantee that is to put it into the building at 55. So all the boilers that have been commissioned since 2005 at flow temperatures of 65, 70 degrees are fundamentally inefficient. Okay, so a heat pump actually is quite comfortable operating at 55 degrees, because if that is the maximum flow temperature required into your radiators, when it's -3 outside or -4 outside, as soon as the air temperature rises, the heat pump intelligence reduces the flow temperature into the radiators to match what's happening outside. It's what we call weather compensation. So what it means is that, yes, it'll be less efficient when it's producing high temperature water, but actually for most of the heating season, it's producing much lower temperature water, because you can heat your house perfectly effectively with maybe 40 degrees in the radiators. So it's a really important point to recognize that whilst, yes, delivering higher temperatures, the heat pumps will be operating at a lower efficiency, the seasonal performance factor, which is what we tend to refer to rather than coefficient of performance, So the annual efficiency is protected by weather compensation. Honest pros and cons. So
can I just make sorry, Bean, can I just interject again to make
yeah.
another trial specific relevant point here on efficiency. A heat pump is always going to be more efficient than a gas boiler, and it's always going to be more efficient than a hydrogen boiler. It's the simple physics of how the things work. And also a heat pump will always be more efficient than direct electric heating. And that's because depending on how the heat pump is set up, for every 1 unit of energy you put into it, you get around 3 out. Whereas for a boiler, for every 1 that you put in, you get 80, 85 if you're lucky, probably less. And similarly for hydrogen. So it's really important to note that as a specific trial specific point, that the heat pump option is going to be more efficient at heating your house than either your gas would be, direct electric would be, or hydrogen would be. Sorry, Bean, I'm just interjecting with the bits that are relevant to the trial.
Again, you're quite right, and the efficiency that we're referring to in that that specific point is energy efficiency. It's not cost efficiency, it's energy efficiency. So units of energy, kilowatt hours. Okay, so that it's very important with that. Now, on its pros and cons. So ground source, relatively expensive, you need space, it can make a bit of a mess in the garden. There are ways of mitigating, and there are ways of deploying ground source where you share effort with neighborhoods and what have you, which can make that much more bearable. But fundamentally, it's relatively expensive. Many people don't like the look of air source machines. And if we were issuing images, and I could send some images through which you can share amongst you if you want, we now have manufacturers and installers who are color coding devices. So you might get one that's painted in a terracotta color to sit in front of a red brick wall. I've seen them with skins on where they've got solid stone skins, wraps, yes, wraps if you like. Green. There's a device coming out of Northern Ireland. It's made by a company called RED, Renewable Energy Devices, now owned by Octopus. It's cylindrical. It looks like a composter. You put that in your garden, actually it doesn't look out of place at all because you just think, oh, that's a composter. So there's a lot of work going on making the visuals more attractive. Noise is frequently cited as being a problem. New generation air source machines are very quiet. They really are. You really get to a point where you have to actually put your hand on it to feel vibration, or hold your hand in front of the exhaust to feel the cold air coming out, to even know that it's on. So they're incredibly quiet. There's a lot of work being done on noise of high density population of air source heat pumps. So where you've got a neighborhood with lots of them, work being done in Salford with Salford University and actually internationally to see what the cumulative effect is. But at the moment, because the devices are becoming so quiet, the impact is likely to be very, very modest, given that you've got background noise in urban environments all the time. The debunking bit, I think we've already touched on some of them. This issue about insulation, noise is another problem. When people make comments about you can't put a heat pump in a hard to treat building, what they're usually really saying is it's expensive to put a heat pump in a hard to treat building. You have to use a bigger device that costs a bit more money, and because electricity is artificially priced highly in the UK, it can cost more to run. But we are, as a country, going to do something about the price of electricity over the next 10 years. The Committee on Climate Change has long held the view that the real price of electricity will be falling in real terms by 2030, probably sooner, because we are going to review the mechanism by which we price electricity, which is currently tied to the price of gas, which is why we've got the immediate problem with tariffs. And the other point to make about electricity tariffs is that we can, as with electric vehicles, I don't know whether any of you are driving electric vehicles, and if you are you currently charging them overnight on low-cost electricity? We can do the same with heat pumps. we can run them on low cost tariffs. We can charge a thermal store, so like an electric battery. You have a heat battery. You charge a thermal store, and then you can bleed that into the building. So there are all sorts of mechanisms that are available now. Right now, this is being done now to reduce the operational cost of heat pumps. So it's very, very common for people to say, oh, you can't put a heat pump there, but actually what they're really referring to is cost. And I believe that the cost issues are going to be mitigated very significantly over the next few years. I saw a note from Kate saying she wants to hold questions. So that's probably enough from me for a while. Richard, Julian, I don't know what you want to add. Peter,
I was just going to say, Bean, yeah, I mean, I've no argument with anything that you said, but traditionally, boilers were cheaper to run than heat pumps, or could be cheaper to run than heat pumps because gas was so heavily subsidised. Those subsidies are going out the window. As regards the insulation measures, insulation is always going to be a good thing, no matter what are your energy sources, whether it's gas, whether it's electricity, whether it's a heat pump. And energy is expensive. And if you can keep that energy in your home rather than having it escaping through walls, out through the roof and all the rest of it, it's got to be the way forward, regardless of your heat source. So, yeah, that's it from me. Some insightful stuff from Bean there, yeah, especially about Norway. I didn't know Norway was 90% on heat pumps. I knew there was a high density of them.
Yeah, it's high.
Scandinavia is hugely involved in heat pumps.
Absolutely, yeah.
They've got a lot of hydroelectric electricity.
Yeah. And they've not. Sorry, Richard, go on.
No. I just want to come in on another myth to debunk, because another quite common reason why it's suggested that, well, in the hydrogen, a lot of the hydrogen narrative, it's like, oh, if you get a hydrogen boiler, it's a like for like swap. You pop one out, you pop the other one in. Well, as I think you're discovering, it's not necessarily quite as straightforward as that. You need to have your home assessment. You need to have a survey done. You'll need to have your meter changed at the very least. You might need to have some of your pipe work changed. You'll have to change your appliances. That's a given. So it's not quite the like for like that they like to present it, but that sounds nice. And the counter to that is, oh, a heat pump, it's really disruptive to have it fitted. Well, you know, I've had my heat pump fitted, and yes, for a couple of days there was some disruption because there's some work going on. They need to put the hot water tank in. They need to run piping, but it took 3 days. Well, it took 2.5 days, and for 2.5 days, I didn't have any heating. I still had hot water because I already had an immersion, so that was fine. But the point being, it was a fairly short space of time, and it's no different than having any work done on your house. There's going to be a degree of mess because if you have work done on your house, there's a bit of mess, right? But they came in on the Monday. By Wednesday afternoon, my house was warm and my house was clean. So it's fairly low level stuff. And obviously you can plan for it because they're not going to arrive unannounced and say, oh, by the way, so you can plan for it. And again, the specific relevance to the trial, as far as I'm aware, Cadent have not really been transparent with how they're going to handle switching you all over. So once they've come and changed your appliances, you are kind of without them until you get hydrogen. Because unless I'm severely mistaken, you can't burn methane in a hydrogen boiler, and you can't burn methane in a hydrogen hob. So for some period of time, you will have nothing. And I'm not sure, well, I'm reasonably confident that Cadent haven't quite figured out how they're going to resolve that one yet either. So there's going to be a period of time when you're going to have nothing. So,
sorry, Richard, I did talk to Cadent about this myself at the outset.
Right.
The plan at the moment is, excuse me, wherever possible, they will, for example, change the boiler as soon as they can.
Yep.
Then on the day of switchover for your particular property, and they'll be doing a certain number in one go, they'll plug off the gas main.
Yep.
They will have one team changing the appliances in the house and retrofitting the boiler. They will have another team working out in the street, and they believe you won't be without any appliances for more than one working day. I don't believe them 1 second, but okay. that's what I can
okay. If they can do that, then that's brilliant, and that isn't a significant amount of disruption. But it's worth really honing in on their plans as to how they're going to actually coordinate all that, because it's a not insignificant challenge to do that. I would argue logistically it's a difficult challenge. Not impossible.
I wouldn't disagree. It's the first time it's been done in the world, so I'm sure they're going to be spot on.
Yeah, and there's a very good point that's been put in the chat about any heat pump that you have installed, which we haven't really touched on, which I will now. That like for like swap that's spoken about with a swapping out your boiler. Well, quite often what they're going to be swapping out is one oversized boiler for another oversized boiler.
Absolutely.
And that's a real problem around efficiency as well, because there's evidence to suggest that there are lots of oversized gas boilers in UK households that could probably heat half the street, not just the house they're in.
Yeah.
So that's an issue. So and because it's oversized, it means it runs very inefficiently. It won't be operating in condensing mode properly. You'll be burning more gas. It will cost you more. There'll be more emissions, all that bad stuff. One thing we haven't really touched on here, which is why I'm glad Julian's here, because he'll pick me up if I get some of this stuff wrong. A heat pump, the whole point of MCS as a standards organization is that you cannot just go in, well, rephrase that, you can just go in and stick a heat pump if you're not an MCS installer. However, every piece of advice out there says you should have an MCS installer for your heat pump. And the reason for that is because they have to do it properly. They have to come in and do a proper heat loss calculation. They'll do a detailed survey of everybody's house. And I've had it done myself. So they do a nice little 3D map. They'll size up your radiators. They'll look at your EPC. They'll calculate your energy demand, and they will size the heat pump and the radiators that you need for your property. Now, to be fair, there's probably some similar properties in the area that will have similar setups. But the point being, to have an MCS installed heat pump, they have to do that. You have to have a heat loss calculation done, a heat loss survey done, which is given to you with detailed plans on what's involved. So that's the design side. That's done for every house that gets a heat pump. And similarly for the installation, there's a whole series of processes that the installers have to go through to make it MCS certified as an installation. And the reason for that, well, the MCS tagline is giving people confidence in homegrown energy. You know, as a householder, you have to have confidence that what's coming into your house is fit for purpose, is going to work as it's supposed to, and keeps you warm with a heat pump. And that's what MCS does. That's the whole purpose of MCS as a standards organization, is to set the benchmark against which heat pumps must be installed. Now, I know at the moment there are some uncertainties around what you'll be offered in terms of a heat pump. I know some of you have had concerns over the fact it's British Gas who would probably be doing it. Well, British Gas has a bit of a name problem because they recognise that they're going to have to transition away from gas. And they are investing heavily in heat pumps. They've got a training academy. They're MCS certified. British Gas are an MCS certified organisation to install heat pumps. They are starting to install lots of heat pumps because that's the direction of travel. If you want to truly decarbonise your heating and future-proof your heating system, for millions of households in the UK, that's going to be a heat pump. And so British Gas, I fully understand why some of you are unsure about, well, British Gas seem to have a foot in both camps here. What's their real interest? Because the Home Assessors, I believe, are British Gas, who are, from what I've heard, saying hydrogen's wonderful, heat pumps aren't the future. Well, there's a separate part of British Gas that would come into your house and say something completely different. But central to that,
PH Jones. It's the social housing division, isn't it?
Yeah. So British Gas are getting into heat pumps in quite a big way. But the most important thing to stress to you and with your conversations with other people in Whitby around the heat pump option is it won't just be someone coming and going, that'll do. It's not like that. No, it's quite a deep, I mean, Julian, correct?
Yeah, absolutely. I mean, a detailed survey is done of every single property heat loss calculations are done on a room by room basis. You will be given a heat emitter schedule which tells you what size radiators you need, your heat loss for the entire property, how many kilowatt hours of energy you will need to heat that property over the course of the year, and projected running costs for your heat pump as well should all be communicated to you at or before the point of sale of the heat pump. This is in the MCS standards, and all our contractors, all our installers have to adhere to these rules. And so it's heavily vetted. They're not just some fly-by-night outfit who just come in and smash any size heat pump into any size home. It's all carefully planned, thought out, all the rest of it.
Can I ask a question on this very point then? Probably a bit early, and Kate will shout at me very loudly. You're talking about radiators, you're talking about heat pump sizes. I'm absolutely certain I'm going to have a huge problem in my property with actual pipe work for the radiators.
Okay.
The biggest pipe I've got is 22 mil. The smallest is 10 mil plastic into radiators. I've got 15 mil feed in the hole upstairs. Now I'm damn sure that is too small, probably even from a gas boiler, but probably going to be too small for a heat pump. But there's a theory in my head that they can just say, okay, we'll bang you in a much bigger heat pump, which will overcome this problem.
Doesn't quite work like that, Keith. Without doing a full survey of your property and having a look to see what pipe sizes you've got and what's going where, I couldn't say exactly whether you'll need a repipe or not. There may be sections of it that need repiping, but you shouldn't need a complete repipe. If you imagine, because what your heat pump's doing, it's producing all the heat for the property, but you're not trying to get all the heat for the property down one piece of pipe. So the piece of pipe that carries all the heat, that might need to be increased in size, but you may not need to increase all the way down to each individual radiator. See where I'm coming from? Because you don't have to get the full 12 kilowatts, for example, down that one bit to the last radiator.
Yeah, no, I understand that concept. I want to be sure myself that if I have British Gas coming into my house to do an MCS survey and fit of a heat pump, under the MCS standards, do they have to take into account that existing piping? And
they should do.
Sizes?
Yes, they should do, most definitely.
Does part of their calculations and their design include a requirement to change pipes where necessary, rather than just put in a bigger heat pump?
Yeah, where necessary. I mean, you can put any size heat pump in as you want. If you ain't got the big enough pipes, it ain't going to work. But they should look at the system holistically. But yeah.
Good, thanks. That's my biggest concern with the heat pump.
Bean, come in.
Can I just interject here that in your particular problem you've identified, Keith, it's not a bigger heat pump, it's bigger circulation pumps.
That's it.
Because what they're trying to overcome is the pressure loss, the increased pressure loss in the smaller diameter pipework. I've just put a note in.
What he said, but he's more eloquent than I am.
Well, I just put a note in. I just put a note in that we have amongst our membership and companies who are not members of the federation either, that have experience and the skills to deal with microbore pipework. Now, I entirely accept that not all installers have that capability, and you might question that legitimately of British Gas, and it's a question that they will need to be able to answer. But I would reassure you that there are installers around who are routinely dealing with microbore pipework.
Absolutely. And I would reassure you that you would not be looking at a full repipe for the system.
No.
To be honest with you, in some ways, a repipe would not concern me too much, given the disruption, because then I'd have a nice brand new.
Well, you're future-proof. If you go down that route, then you're completely future-proof, no matter what. But as you say, it could be that it's undersized for a boiler-based system. Exactly. Never mind, we just don't know. Without doing a full detailed survey and looking at what's going where and doing what, we can't really tell. But your surveyor should be able to look at that as well.
Right. I'm ex-engineering, Julian, so I appreciate the lack of eloquence.
Just one other point on that, because I also know from speaking with some of you that one of your concerns is that the only option that you might have is what British Gas tell you, and that you won't, do what we'd all normally do of get 2 or 3 quotes. And again, I fully understand that would be a concern. There's 2 ways I'll try and reassure you with that. One is the fact that British Gas are MCS certified, and this project. Let's just take a step back. I have a background in social science research, and I've worked with community groups in a whole range of different sustainability related issues. And I had conversations with Cadent a year ago about members of Cadent about a year ago about this trial, and they were saying, oh, it's going to be great, we're going to do this, we're going to do that. And I said to them, do you know what? As soon as you start dealing with people who you're trying to do stuff to, not with, you're going to have all sorts of problems. And lo and behold, what's happened? They're having all sorts of problems around their engagement and their lack of transparency. And so you are all rightly asking loads of really good questions of them. In relation to the heat pump issue, one of the ways to get that security is the fact that they are MCS certified. Now, yes, you can't get 2 or 3 people in to tell you what might be a different option. My slightly, what's the way to phrase it? A free heat pump offered by British Gas through this trial is the best way to future-proof your heating system regardless. And Julian and I had a meeting a couple of days ago with some other people within MCS about how MCS as an organisation might be able to provide an extra level of assurance to the trial. Now, we haven't, because some of the finer points of how the trial is going to operate haven't been finalised yet, we haven't had, MCS hasn't had conversations yet specifically with British Gas around the heat pumps. So I can't guarantee you what our involvement would be, because it might be that British Gas, even though they're certified, might not want us to be too closely involved. I don't know. But we're having conversations around how we might be able to provide an extra level of assurance on the fact that what you're getting is fit for purpose. But just to reiterate, MCS is there for a reason, and it's there to set the standards against which they have to do things. And whilst British Gas have an interest in hydrogen, they have a growing interest in heat pumps. And the last thing they would want is for a whole series of poorly designed and poorly installed systems, because it would massively undermine a significant chunk of their business plan going forward.
Richard, Richard.
Yes, Peter.
I'm going to spend a lot of time in respect for what MCS does, but you do represent an awful lot of companies at the larger end, largest end, potentially British Gas, and at the smallest end, we'll be talking about maybe a couple of people, husband and wife, perhaps, albeit that sort of size. They may be working through an umbrella organisation due to the paperwork burden. If we are honest, we all know that there are significantly varying standards. I've worked for an MCS installer a long time ago, well before your time at MCS, and not necessarily relevant for now. I had a bad experience with a solar installer who was MCS registered. Didn't stop them leaving the job half done, and MCS didn't want to know when I got in touch. It does absolutely no harm for people in Whitby to have a choice. There are a significant number of MCS installers who, for whatever reason, perhaps they're too busy, perhaps they don't have the skills, will not take on microbore. I know this personally. It's not wrong. It just is what it is, and people like Bean can point them in the right direction. Maybe you can too. Maybe British Gas has got some engineers who are happy to do this. If you look at someone like Octopus, though, I don't think they're going to be doing too many microbores if they can avoid it. They've got their model and they're cherry picking the easy installs. People should have a choice, and that should extend to British Gas and other heat pump installers that they might want to go to. And there should be some sort of scheme that gets an equivalent value for them. And certainly in my opinion, and I know that's the opinion of other people who are involved in this on the advisory side.
I wouldn't dispute that for a second, Peter, but unfortunately, I'm not designing the trial. You know, I would absolutely recommend that if it's an option for people, in every other situation in life, if you were looking at making a significant investment such as a heat pump, of course you would. Now, you know, I haven't designed the trial, So what my job here is to try and reassure people as much as possible that a heat pump is a viable option, and that we can do what we can to support them. Of course, you know, get extra quotes, get a second opinion. One of the problems that you might encounter in getting a second opinion from an installer is once they know that you're in the trial area, they're probably going to be where you're not going to buy it from them, and that's you know, because you're going to get it for free through British Gas. So that's part of what I'm saying about, you know, where MCS, we haven't figured out how we can help in this yet, but we are trying to find a way, bearing in mind that we are not part of the trial. You know, we have nothing to do with the trial whatsoever, other than trying to support residents make a truly informed choice, which Cadent are spectacularly failing in doing so. So I completely and accept your point. Yeah, sure. You know, in an ideal world, get 2 or 3 quotes, but British Gas are not going to say, here's our quote, and we're going to pay for 2 other people to come in and do a heat loss calculation for you, etc., etc. You know, and again, this gets back to my point I made a minute ago. You know, Cadent have designed this trial without really thinking it through, and now it's smacking them in the face because they're coming up against issues like the one you're talking about. I completely agree with you. In an ideal world, you would get 2 or 3 quotes. The Whitby Village trial is not an ideal world, and I don't know how else to answer that.
Well, I mean, I think that's a good answer. And all I would say there is there's been a clear demand from the Whitby residents to have the choice of the free install from different installers. So I think what would really make them happy, Richard, is for the MCS to back them strongly on that point in public, in the press.
Well, I think you'll find that my voice on this is quite strong, Peter. I don't think I'm holding back on what I'm saying. But
purely from a recipient of this trial.
Yeah.
Can I sort of try and throw some sort of pragmatic option in here? We're getting British Gas. We're not going to be given any choice. I think that's 99% certainty. But what I would like is a reasonably priced, and I would pay for it, sanity check on what they come out with in terms of a heat pump installation design for my property.
I've just made that.
Okay. Well, can I make on that point, Keith? I mean, as I said a second ago, MCS hasn't quite figured out how we can support the trial. Maybe that's one way we can look at doing that. Julian?
Sorry, I was just trying to reply to Karen's question in the chat. Sorry, go again, say again, Keith.
Sorry, what I was saying was, we're going to get British Gas doing this.
Mm-hmm.
They're going to do the minimum they can get away with. I certainly don't believe they will pay for anybody else to do the job or pay for anybody else to come in and do a design. Personally, and I'm speaking purely personally here, I would be happy if I could pay a reasonable price to get their design sanity checked, given the circumstances in my property. I suspect there's other members of the group who would be happy to do the same. I don't know, but I'm only speaking for myself. And that's the sort of thing I'm looking at. I've looked at heat pump Facebook groups where people are saying, yeah, we'll do you a survey. We'll charge you 300, 400, 500, 600 pounds for it. I mean, that's silly money to me for a sanity check. But I don't know. But, you know, reasonable sort of money, just so we can say, here's the design they've come up with for my property. Does it look there or thereabouts, or is it obviously a million miles away?
There are organisations who can help you with that out there, private organisations, yeah. Bean, you've got your hand up. Did you want to?
Yeah, a couple of things that I might just
Pump Association.
Yeah. So when the government did the heat pump demonstrator programme, there was a level of oversight from an independent party. So potentially, Cadent / British Gas could engage a level of oversight, which would perhaps start to address some of the concerns you have, Keith. The other thing I would add, which Richard hasn't mentioned yet, and I'm sure he's going to at some point, but I'm going to prompt him, is that apart from being the holders of the standards for the installation of microgeneration technologies, MCS also provides Peter sort of alluded to it a minute ago, also provides a degree of safety net. So there is a growing willingness and ability within MCS. And I don't know when Peter had his problem when he said his solar PV wasn't going well and MCS didn't want to know. But just to give you a bit of background, MCS used to be owned by the government, and it was novated, so transferred. Ownership was transferred to the charitable foundation in about 2017, and at that point, the new CEO of the service company, that's the operational layer, Ian Rippon, was brought in. Ian gets customer.
He does.
He gets customer engagement. He gets customer satisfaction. He gets the requirement for consumers to be secure, and so he had spent the last few years strengthening the ability of MCS to look after consumers. And I've seen this because we do get complaints coming into to the federation, with people saying that they've got problems, systems that don't work properly, and actually I have worked through a number of those with MCS and found not only a growing willingness but also a growing ability. They're bringing in technical ability into their organisation to be able to audit systems and to hold installers to account. And in fact, only a week ago, I got an email from somebody in Norfolk saying that they've just had their installer back, they've rectified the problems, and they're absolutely delighted. Partly because we got involved because we know the system, but if we can educate consumers so that they know how to manage that part of what they're doing, then I think we'll be doing everybody a service. And of course, at the end of the day, people like us are there. As I say, we get emails from consumers asking for assistance in all sorts of ways. Pre-decision whilst they're going through buying. Sometimes if they've got a problem at the end, but there are. I guess what I'm trying to say is there are places where you can turn to for help, and MCS will provide this layer of consumer protection that will, I think, allow you to build up your level of consumer confidence. And once you have confidence, then you can start thinking about the marketplace. I entirely sympathise with your thinking that you need potentially to have the choice of where to go for an install. I get that Cadent want to have a party with whom they've negotiated some sort of financial arrangement, I guess. But you might say to them, well, look, let's have the financial arrangement as a cash alternative, and then you could go off into the marketplace and benefit from the boiler upgrade scheme potentially. That might be something that's worth putting to Cadent. I suspect they probably wouldn't like it very much, but it's certainly something that, as a residents community group, you would be perfectly reasonable in asking.
Yeah, and I think that, Bean's absolutely right about the consumer confidence angle to MCS as well. So thanks, Bean. Thanks for the prompt. And again, I know it's one of the frustrations around this whole idea. I'm going to say the phrase a few times tonight. This whole idea of informed choice is something that you are not being given here. And I know that part of the frustration is you don't know what form that heat pump offer might take. And so I know from conversations with Kate and following what's going on Facebook that you're looking to address that. My instinct would be that Kate, because Cadent just supply the gas. It's British Gas who are going to have got the foot in both camps here for the boiler, changing the boilers, changing the heat pumps. My instinct is that they would be reluctant to say, here's a cash equivalent, go and find someone. But that doesn't mean you shouldn't push for it. And equally, Keith, your idea about the sense check, I can take that back to separate conversations within MCS as to how we might be able to support the residents. But we are very supportive, but we have to wait to see how Cadent and British Gas do the final design of what they intend to do to you, not with you. And then we'll have a better idea of where we can best engage with whoever we need to engage with. But we're so I wear two hats. I wear the charitable foundation hat, but also the company hat. And talking with my company hat, we are quite keen to support good quality heat pump installations across the entire UK, and that would include in Whitby.
Yep. I should point out as well that all our members are members of what's called a consumer code, an organisation such as REC or HISE, which offers a degree of consumer protection as well on a contractual basis.
Yeah.
You're on mute, B.
Schoolboy error, reach for the mute button. I don't know, Kate, how you feel this conversation is going, but I'm acutely aware of time, and I just wonder whether you want to make sure that we get to address the questions which you set out in your email.
Yeah, Peter, how long have we got on the call? Was it an hour or an hour and a half tonight?
You've got as long as you want, really. I don't know what people's time, like being in particular, is. I've got no particular plans, and if I have a plan, I can just leave the computer on anyway. I've got a hand raised. We've got the questions. I wonder, before we move away too much from this, and kind of picking up Keith's point, whether it might be worth you saying just a few words. And if it's been a while for you, I'm sure it hasn't. I can go through this as well, about what the process is of designing a heat pump, and just very briefly, what might go into the sanity check. So I can see a few fairly low cost options, but really to get a proper handle on it, my feel is that a reasonable amount of work needs to be done. So what's your much more expert opinion?
What on the way that the systems would be designed and sized?
Yeah, so Keith is, sorry to pick on you, Keith, but Keith is looking to get a BG heat pump installed. You've heard some of his issues. How might one get a sanitary check that what BG is proposing is sensible? And then maybe for much more of a bog standard house, same question.
Yeah, I've just sort of put a comment. Karen Milne had said that some residents are already being told their homes are not suitable for heat pumps. Well, I think that that's untrue, but I suspect there's an element here that says there's a budget in place per house, and British Gas are looking in the same way that Octopus do. And someone mentioned Octopus; they're members of the Federation, and you're quite right. They do walk away from microbore sites because they are going after a particular demographic at a price. And so I suspect that BG are saying, we can't do this property at that price, therefore we'll say it's not suitable.
I think it's more fundamental than that, Bean.
Those two things are not the same.
But I personally, Ben, I think it's more fundamental in that British Gas / hydrogen division is not talking to British Gas heat pump division. So the people doing the assessments and saying it's not suitable, that's because someone higher up in their food chain is quite likely to, and I'm doing this anecdotally just to caveat that for the record. There will be a filter, because there was I posted on the Facebook page earlier today about this very thing. Assessors coming in and saying, one of the posts was, your home's not suitable for a heat pump. You know, go for hydrogen. Japan's gone all in on hydrogen. Oh, and they've got carbon capture and storage working as well. Well, yes, exactly. So the responses to that are, well, where's your evidence? So why are you telling me that my home's not suitable when all homes are suitable for heat pumps? And the anecdotal stuff about Japan, well, Japan doesn't have hydrogen going all in at all, and they don't have any carbon capture and storage at all. So if nothing else, and I, as I posted on that Facebook post, at the very least ask, why are you saying that? Where's your evidence for that? Can, you know, where have you heard that? How can you support that statement? Because I've seen research that suggests otherwise. And, you know, because most likely the people doing the assessors, and I don't wish to denigrate them or, you know, but you know, they don't spend their life like I do reading hydrogen business models from BEIS on how to fund all this stuff. They don't spend their life stuck in energy policy and, you know, the minute details of how the hydrogen economy might work, which, you know, for my sins is a significant chunk of my day job. So my point being is that some of the information that you're being fed is information that has been fed to those people, and it's not necessarily very good information. So at the very least, it's like, why are you saying that? You know, where's your evidence for that? How can you back that up? And then they're probably not going to have a bit of a mumble and go, I would imagine.
Richard, Pat has got a hand up.
Oh, sorry, Pat.
Yes. I have two questions. I've currently got a combi boiler in the loft and I have no hot water tank. With a heat pump, my first question is, do I have to have a hot water tank? And my second question is, can the heat pump be attached to the wall high up at the level that the combi boiler currently is?
Okay, that's probably one for me to start with, Julian, but you may want to hop in at some point. So
yeah, I'll jump in definitely. But yeah,
the first part of your question, do you have to have a hot water cylinder? Strictly speaking, the answer is no, because we have heat pump systems that include the ability to do instantaneous hot water. They're incredibly rare, and I suspect they wouldn't be included in this trial because they're also expensive. But strictly speaking, you don't need a cylinder. The reality is that for most heat pump deployments, you would need a hot water cylinder. Now, that hot water cylinder would need to be sized properly against your bathrooms, the type of shower fittings and what have you. And it could go in the loft.
Absolutely agree. Absolutely nothing to stop the cylinder going in the loft where the boiler is at the moment, Pat.
The second part of your question, could the heat pump go on the wall where the boiler is? No, it can't, because the air source heat pump, if it is air source, needs to be on the outside.
Got to be outside, yeah.
So,
but can it go on the outside, high up?
Yes,
They can be mounted high. Sorry, Bean.
It could be mounted at height. The only issue around mounting at height is that you are automatically adding to your maintenance costs, because every single year when the unit is serviced, the service providers will need to, first of all, almost certainly for health and safety, there'll need to be two of them rather than one engineer, and they'll have to have working at height capability. So yes, it can, and I see lots of heat pumps being deployed on brackets, high up, in the same way that air conditioning units are routinely mounted high up. But if the intention is to have them serviced, then you've just got to be mindful that you're probably adding to your service costs.
And like for like, which is what they say, could be a heat pump with no water cylinder, because that's what I've currently got. Well,
that's an interesting argument to put to them in the paperwork that they provided, where they say it's like for like, i.e. you don't need a cylinder. In which case, I would say, well, that's fine. Fit this lovely CTC unit, which gives you instantaneous hot water.
Yeah.
So you're quite right. That's a very clever interpretation of their written word, Pat.
Yeah.
Thank you. Thank you for the answers.
Do you want the job?
I think to be in the interest of transparency, they've already said in the handbook you will need space for a hot water tank, a heat exchanger, and 2 pressure vessels within your property.
Thank you so much for mentioning that, Keith, because that's something I wanted to address as well. That information brochure is not accurate.
No.
It's and I don't know, it's not accurate, and I'm so glad that you mentioned that, because of all the stuff you need a hot water. I can't remember the exact wording on it. I can probably look it up and find out. But Bean, do you want to explain the mechanics more of it?
Yeah, I mean, I haven't read the document fully, but I was asked to look at a couple of pages and identify just some simple problems, so that you sort of say, well, here are some simple problems with this document, and therefore one would question the rest of it. I think the question about needing space, yes. The question about expansion vessels. You know, if your system is pressurized, you need expansion vessels.
Yeah.
It's not whether it's a heat pump or not. If the system is pressurized, heating and hot water, you need expansion vessels.
You do.
So that is a bit of a red herring, and it's very easy for them to make it look as if that's a heat pump requirement. It isn't. And it's an interesting question to understand how many of you actually have pressurized systems. You know, if a lot of you are still on vented systems, you won't have expansion vessels. But if your new hydrogen boilers are being deployed in a pressurized methodology, you'll need the expansion vessels. So that is not a heat pump requirement. So there immediately you've got something which they have put down in writing, which makes the heat pump look less attractive. But actually, it's not a heat pump requirement at all.
Yeah. Can I just go through a few more of those? I've actually got it on my screen now. Many homes. So in the information that you were given, it says many homes will need new, larger radiators or underfloor heating to increase efficiency. Well, I know a few of you have been worrying about underfloor heating. You don't need underfloor heating. If you were doing a complete retrofit of your house and ripping everything out and starting from scratch, sure. I have a heat pump. I changed some of my radiators, not all of them. I don't have underfloor heating. You do not need underfloor heating. If you build a new build house, by all means, put in a heat pump with underfloor heating because you can run at a much lower temperature and it's much more efficient. But you do not need underfloor heating. You do not need a heat recovery unit. You do not need 2 expansion vessels. That is simply not true. And then similarly up at the top when they're describing air source heat pumps, where it says they require a large fan to be placed outside where it can draw in the air from which it will absorb the heat. Well, the way that's written suggests that you need to have some sort of 6-foot fan stuck on your fence overlooking your neighbours. Well, you don't. You do need a fan because that's the fundamental part of the air source heat pump's heat transfer system, but it's contained in the heat pump unit. So you're not going to have some fan whirring away like mad, posing a risk to you and your neighbour's fingers. It's not like that. But the way it's written, it presents like that, and it's simply not true. And as been alluded to, you know, the design of them is changing. Some of them are almost attractive. There's, if any of you are on Twitter, there's a Twitter.
Sorry, Richard, we said earlier that the heat pumps, there's many companies out there who are making attractive wraps to make them look more attractive and fit in better with their surroundings. Bean said there's one that looks like a composter now coming over from Northern Ireland. They are not unsightly. You know, they're not this horrible ogre kind of thing that they're being painted. And also, I'd like to say, going back to the question about hot water cylinders, I mean, what are people's objections to hot water cylinders? Do you not want mains pressure hot water coming out of your taps?
I think some of the.
It's all about space.
Yeah, but I mean, if you, as in Pat's case, the boiler's in the loft. There's nothing to prevent the cylinder from going up in the loft. And I think modern cylinders are what we call unvented, so they're mains fed. Sorry, I'm speaking over you there. Go on.
No, I was just going to say it's been raised a few times because over the probably the last 5-10 years. Tanks in the loft is a bit of an old thing. People have since removed them all out and had loft conversions and things like that. So I suppose it's putting it back is then trying to find the space to put something back.
Okay, yeah, I understand.
That's what I've got. My loft, the combi boiler is tucked into a cupboard, and then the rest of that area is part of the loft conversion.
I see where you're coming from.
Yeah.
This is routinely a space question.
Yes.
And there are a number of approaches that can mitigate against space requirements. One would be to use phase change storage, which is about a quarter of the volume of a hot water cylinder. More expensive, but much more compact.
What did he say? Storage?
It's
phase
change materials. So phase change materials. If you look at a company called Sunamp, based in Scotland, they're the leading exponents of phase change storage. and you get the equivalent energy store for about 25% of the volume of a hot water cylinder.
That must be the
So-
thermal battery that I've.
Sorry? It's a thermal battery, effectively, yes,
Yeah.
and it can deal with both heating and hot water. So that's one option. One of the things we're doing creatively, and this doesn't apply everywhere, but you know, we need to look for the right solution for each dwelling. We've got a site down on the south coast where we're doing a whole load of retrofit cottages, estate cottages. They're all stone, solid stone, no problems with putting heat pumps in them. And to provide the space for the cylinders, what we've done is we've looked for the footprint of the old outside loo. And we've rebuilt the outside loo and put the cylinder in it. So yeah, there are all sorts of creative things that one can do to find space for these things. And I firmly believe that as time moves on, what this will now do, because architects and builders relied on combi boilers to save space, what they will, what we'll now see is cylinder manufacturers and storage manufacturers starting to be creative about the shapes of their devices. So cylinders inherently are sort of quite wasteful in space terms, but I think we'll see some different form factors coming through. So I'm just going to address this one about the loft. Someone, Mr. Catherall, if I pronounced that correctly, has asked about why it can't go in the loft. And I said, well, because it needs external air in order to harvest fresh energy. And there are heat pumps called exhaust air heat pumps, which recover heat from inside the building. They are designed for highly insulated micro apartments. They are not suitable for retrofitting into average homes in the UK. So with an air source heat pump, you fundamentally do need to have that external unit. Okay, because if you put it in your loft and you turn it on, it would have sucked the heat from the loft in minutes, and then you're in trouble.
Yeah.
So you absolutely have to have outside. What we are seeing is some units coming through now that are ducted to outside. So the device is on the inside and it has ductwork going to the outside, both for the intake and for the exhaust. But more space because you've got ductwork, and actually ductwork tends to increase the noise, because as soon as you start bending the air and turning it around corners, you're increasing the noise of the airflow. Do they have to be attached to the house? No, they can go down the garden, they can go anywhere you like, as long as they've got free airflow, both for the input, which tends to be at the back, and the exhaust at the front, because what you don't want is for the device to recycle its own cold air. So if it's pointing at a fence, potentially the cold air bounces back and gets sucked by the device. So you've got to allow free space. Manufacturers normally ask for between 1 and 3 meters of free space in front.
Can I make
Not
a
the new
suggestion?
Mitsubishi's been. The new Mitsis, they only need 600 millimeters or 2 feet in front of them, and they only need a minimum of 100 millimeters or 4 inches behind. Yes, they do stay. Good airflow is required, but they can be put into quite a small space. Can these things? So yeah. Sorry, Richard.
Maybe.
In the interest of focusing on the specifics of the trial, should we get through some of those other questions that people have got? Because I mean, heat pumps are amazing things. They come in all different shapes and sizes and can do all different sorts of jobs in all sorts of different houses.
Yep.
And again, what I'm really keen to get through to you is answering your key questions, but in recognition that you are, again, because you're not really being given an informed choice here or a real option, you are not going to have a shopping list of, can I please have, rephrase that. I'm imagining that you're unlikely to have a huge range of choice. So what I'm really keen, I mean, what you will be offered will be probably a Vaillant or a Worcester Bosch or a Mitsubishi or other heat pump brands available. You will be offered a perfectly functional MCS certified heat pump to heat your house. And so whilst we could get in the discussion of all the different options that might exist if you were buying it yourself, unfortunately, unless some of you choose to, you are going to be taking what British Gas offer you. So if there are some more general questions specific to that type of thing, I think you know, I'm more than happy, I'm sure Bean, I'm sure Julian is too, you know, to have a very long conversation on heat pump possibilities. But I think we just need to be mindful that unfortunately, you are not in the situation that you're going to have a free choice in this necessarily. So what I'm keen is to reassure you that what they offer you, A, will be suitable, and B, will do what you need it to do. And if that's
thanks, Richard. And I think that actually answers probably some questions that we've had through anyway, which is around, you know, like you would with a car, you've got different brands and models. So would that be the same for heat pumps? Well, I suppose the short answer is yes, but those options might not be available probably won't be available to us, because they would come with a higher price tag, and ultimately the project will have a line in the sand in what they will pay for us. So again, I mean, but personally, I will have to jump off in a couple of minutes, because I actually need to go and get ready to travel for my other job. So I will be dipping off. I'm thinking, because we have got quite a few questions coming through anyway, is there a possibility that I could maybe email them and work with you on the side, and then bring them back into the Facebook group as a bit of an FAQ session, and maybe the ones that we've had posted, and maybe just the people on the call ask live questions now?
Yeah, I'm happy. I'm happy either way. I mean, we've addressed some of the questions in the list that you emailed through, Kate. Whether you want to quickly bang through that list, because some of them are very quick answers, and then I'm more than happy to sit here and take questions from the floor, as long as people want to, frankly.
Okay.
I think it's important that you get good good information, which isn't, we're not saying, our organisation is not here to say you must all buy a heat pump. What we want to make sure is that if you do decide that a heat pump is right for you, that what you get is what you should get.
Absolutely.
So very, very quickly then, do they run 24/7? No is the answer. They run when there's heat demand. Okay, so that's the first thing. Electricity draw depends clearly on the size of the load. When not heating or cooling, needed to have a hot water supply. Yes, they'll provide hot water in the summer. You could have solar thermal and supplement that. So you could have solar thermal doing your hot water in the summer. Equally, you could have solar PV with a diverter, putting the PV into an immersion in your hot water cylinder. So there are a number of ways of configuring hot water in the summer. You don't necessarily have to run the heat pump if you've got your own solar PV. So that's an open.
That's a very common thing that Bean's just mentioned there. I see that type of system quite a lot, where you've got PV generating electricity, and that's used to power an immersion heater in summer when you don't want the heat pump running. Sorry, Bean.
It's not a question of not wanting the heat pump. It's just you've got to look in the whole and say, what is the most effective way of running this house? Given we've got some PV, we've got a heat pump. Would solar battery provide enough electricity to support a good chunk of the power for the heat pump? No. Again, that's the proverbial how long's a piece of string. How big's the battery? How big is the heat pump? Broadly speaking, you'd have to have a relatively chunky electrical battery to be able to power a heat pump. But the alternative is you store the heat and you use your battery potentially to run the circulation pump. So again, there are alternative ways of matching storage with either tariffs or other technologies that you might have. Feasible for primary heating source to be the heat pump with an electric boiler? Yes. You wouldn't need to boost the temperature though. We have high temperature devices now. It's a very brave person that stands under a shower at more than about 43 degrees. And we routinely store hot water at 60. And we've got plenty of heat pumps that will give you 60 degrees. So you won't need a boiler to boost the temperature. Okay, so there will be no requirement in a well-specified heat pump system, no requirement for a backup device in order to provide additional boost of anything. Thinking boiler only runs sporadically and only when it's particularly cold. Okay, so that's I think a reflection of, you might have heard of a hybrid approach that says heat pump does most of the work. When it gets really cold, switch to the boiler. The problem with that is you're now maintaining and servicing two devices, and at some point the boiler element will be withdrawn, and then you are potentially left with an undersized heat. So actually much better that you go to the correctly sized heat pump right at the outset. And if you need a high temperature device, so be it, because it's only going to operate, as I set out earlier, at high temperature for a small number of hours a year. There's a question about suitably qualified engineers to service heat pumps. Now, most installers will probably offer you
service package.
a service package.
Yep.
Okay, so normally your installation would come, it'll probably come with a 7-year warranty, and you would be able to enter into a service package. And people like big players like British Gas and Octopus will absolutely offer service packages. We have now some independent service companies appearing. So they're not installers, they're just doing service. They're very rare, but clearly, as the market grows, that will be a growing part of the market. Due to lower heat output of underfloor heating, better for heat pumps. Yes, as we said, the lower the flow temperature, the more efficient the heat pump will be. Same applies to the boiler.
Absolutely.
But it's not a prerequisite. I think that's the key. It's not a prerequisite. One of the advantages of underfloor heating is it forces you to insulate the floor. And actually what you're doing then is, of course, reducing your heat loss. So you could get half the benefit by just putting insulation in the floor, not worrying about underfloor heating, but just insulating. And if you can do that from underneath, actually that's a really good thing to do to reduce your heat loss.
There are companies out there who specialise in doing that underfloor insulation, they call it, and they'll fit insulation in between your joists if you have a suspended ground floor, and it does massively reduce your heat losses. But that goes back to what I was saying anyway, regardless of your heat source, be it a boiler heat or heat pump, reduce your heat losses if you can, wherever possible.
Yeah. Does the heat pump supply hot water to the tank in summer? Yes, absolutely, can do. Could be done by, you'd only really choose to do it with an immersion if you've got your own solar PV electrical generation, because otherwise you're giving away the efficiency of running the heat pump. Do you need an immersion? No, you don't, but I would suggest to you that most cylinders you would put an immersion in, because that is your backup device if, God forbid, you have a compressor failure. Compressor failures, I must tell you, are incredibly rare. I mean, but boilers break down occasionally, heat pumps break down occasionally, no more, I would suggest, than one than the other. So always sensible. Immersions are very cheap. Always sensible to put an immersion in the hot water cylinder so that you can switch it on if you were to have a problem. Can a heat pump work efficiently in a house with wooden suspended floors? Absolutely, yes. We've touched on this issue about double glazing. Our property does not have an EPC. Do we need one in order for the heat pump to be installed? No. Do we need one to be eligible for the boiler upgrade scheme? Yes. You do. And the EPC needs to have no recommendations for either loft insulation or cavity wall insulation. So if your EPC says your loft insulation isn't good enough, or you've got cavities that are unfilled, you will need to address that, or get an engineer's report to say that your cavities can't be filled because blah, 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 blah. So yes, you will need an EPC to qualify for the boiler upgrade scheme. And I am pretty confident that Cadent British Gas will want to access the boiler upgrade scheme, because it's a way of significantly reducing their cost of providing the heat pump alternative. If the property is unsuitable for cavity wall, get that. Do you need you will need some form of recognised expert to provide you with that exemption. It cannot be done by the domestic energy assessor on their own. Okay. Someone's put a note about Mixergy. Mixergy cylinders, actually very interesting technology. It's just a variant of what we would now term to be a smart cylinder that has capability of taking in inputs from PV, from an immersion, from a heat pump, from a boiler.
Sorry, I missed that question.
And making the best of them. We are increasingly moving towards what we refer to as the smart home. And so this is just an early iteration of one of the smart devices that we will all ultimately have. And Peter also put a note about the need for a new cylinder with a bigger coil. So if you've got an existing hot water cylinder, the chances are that it will still need to be replaced because the coil inside it will be sized for a boiler and sized for a boiler operating at 70 degrees, probably. We don't want to operate the heat pumps at that level, even though we have heat pumps that will give that. I've got heat pumps that will give you 130 degrees if you wanted it. Yeah, almost certainly you would need to have the cylinder changed so that it comes with a coil which is correctly sized for the flow temperature we want the heat pump to operate at. So that's my
just to be clear on that, Bean, if the coil in the cylinder is too small, at the minimum it will take an awfully long time to heat the water up, but it can also cause problems with the way that the heat pump operates if the temperature that the water goes to the cylinder is too close to the temperature it comes back from the cylinder. So basically, frustrating as it seems, even if you've got almost a brand new cylinder, frankly, it's still going to need to get changed to have a heat pump.
If you have a brand new cylinder and this all goes ahead and it needs replacing, don't let them take the cylinder away. Put it on eBay yourself.
Yeah.
Because that's what they'll do.
On the cavity wall insulation and the underfloor insulation, I've organised a lot of cavity wall insulation in my company that I'm no longer involved in, so no vested interest. We fitted underfloor insulation. I know your area of the country from doing cavity wall insulation. It's pretty windy there. We did a couple of blocks of flats right on Lytham St Anne's in front of the Atlantic. There are really good cavity wall products. The bonded bead. It's rated for all exposure zones. It's a bit like heat pumps. If you get a good quality installer, it will work. It will do the job for you. It comes with a 25-year insurance back guarantee. Don't kick cavity wall into touch just because it's windy and you've got wind-driven rain there. Underfloor insulation, second what's been said, it's very difficult to do if you've got solid floors. If you've got suspended timber floors, there's a prescribed standard now which I'm not a huge fan of because it involves using Celotex, which comes with a few issues. The way we used to do it was okay at the time, but is now not quite enough. I mean, what we were doing was raising one in every 4 or 5 floorboards, friction fitting Rockwell mineral slab, which is the way I was taught to do it by a very experienced installation fitter and surveyor. Because that's got a bit of give, it will take up any room, any irregularities between the joists. The key point, I think, I haven't thought this through fully, but I'm pretty sure you could do the same with Celotex. No, it'd be harder. You don't need to lift your entire floorboards up, is what I'm trying to say here. Some people try and do it using robots. There's different approaches. It's worth having a look at getting underfloor insulation done if you've got suspended, but not if you've got solid. Effectively,
there are insulation contractors who will actually get under the floor if there's a crawl space under the floor, and crawl spaces from underneath.
Yeah, if you've got a big enough crawl space, we had a thin lad that would go under the crawl spaces.
Actually on ash and there underneath the street.
What's that?
A question about too small. The width of your cavity. Do you know how wide it actually is? This is Karen. But okay, I don't know where Karen's got to, but no, it wouldn't mean that you can't have a heat pump. if you've got a cavity which is too narrow to insulate, then if the EPC assessor's on his or her game, then that won't come up as a recommendation. Worst case, you need to get a chartered surveyor or somebody else so to be qualified to give an opinion that says that the property isn't suitable for insulation. I had one question been which I've done a little bit of an effort to answer direct. I think it's another how long is a piece of string question, really. What's the impact of adding a buffer storage tank into the efficiency of a heat pump system?
Good question.
Okay, so how long have we got, and how technical do you want this to get?
Well, I guess before we go too far, what is a buffer tank?
Yeah, so funny enough, I actually answered a question via email to somebody else on this earlier. So a buffer, fundamentally it's a cylinder, another cylinder of water. So in addition to your hot water cylinder, it's another cylinder, so more space requirement, but sometimes referred to as a thermal store or possibly a volumizer. Technically, they all do slightly different things, but the terminologies get cross-referenced. Julian, you got your hands up.
Yeah, just on the point of it taking up more space, being another cylinder, there are manufacturers out there who make a combined hot water storage cylinder and buffer vessels. So the buffer vessel is actually underneath the hot water storage cylinder. So if you've got enough height, you can get this unit in, and the footprint of it is exactly the same as an existing hot water storage cylinder. They're a brilliant solution where space might be tight. Yeah. Anyway, back to Bean's talk on buffer vessels.
You're right, and actually, of course, we also have heat pumps that have cylinders built into them. We do. And some of them have buffers built in. So there are ways of constricting the footprint, but fundamentally, it's a second cylinder. There are multiple schools of thought. It's a bit like, you ask 100 lawyers for a legal opinion on something, you'll get 100 different answers. And if you ask 100 heat pump installers about buffers, you'll probably get 100 different answers. Some people in our industry loathe buffers. They say that they are an unnecessary inefficiency because it's another heat exchanger effectively. So you're transferring, you're storing energy. They do lose heat. Yes, Karen, I was referring to the boiler upgrade scheme. The other school of thought is that a buffer allows you to flatten out peaks and troughs in demand. Now, this is where it starts to get slightly technical. Up until relatively recently, most heat pumps had fixed speed compressors. So it means that once they're on, they're running at a fixed speed. Most modern air source heat pumps have variable speed compressors, which means that they will ramp up and down to match the heat demand that your house is presenting, and that will depend on how cold it is outside. So spring and autumn, less heat demand, winter, more heat demand. The theory is that if you've got a variable speed compressor, the requirement for a buffer has gone away.
Bean, could I just interrupt you for a second, if you don't mind?
Yeah.
Without, well, and I'm more than happy to be contradicted or spoken of. After an hour and 40 minutes of all things heat pump, I'm not sure if we need to get into a detailed conversation. And I could be wrong, and good people will please tell me if I am. Right. But what I'm very keen after an hour and 40 is that if there's any unanswered questions, I know Keith's got his hand up. Those of you who want to know the minutiae of the different design options, feel free to contact us because we're close by and happy to talk. But what I'm really keen to ensure is that if there's any other queries or any way in which you might be uncertain as to whether a heat pump is actually a viable option, then how can we address that? And Ben, I don't mean to be disrespectful by stopping you.
No, you're right, and that's why I said, how long have you got and how technical do you want it to be. The one I would
Well,
make is this.
Can I just jump in? It was my question. So if I could take that offline with you, I'm perfectly happy to do so, because I am interested in the technical aspects, because I know it's suitable for my house because I've got underfloor.
There you
Excellent.
go.
Well,
I've just put, sorry, Bean, I've
contact
just
us.
put in the chat the email address for us at MCS, help@mcscertified.com. So if you want to email any questions into that, we will try and get through them. But be warned, the technical team at MCS is quite small, so it may take a while.
Yeah.
Just put myself right in the crosshairs there, haven't I?
I want to make one point about buffers.
Can I just make one quick point about that email address first, Bean? If you do send an email to that email address, please put in the subject title Whitby Village, so we know it's coming from you, so we can possibly triage them and get them answered a bit quicker.
Thank you, Richard. Yeah, Bean.
Sorry, Bean. One point I'd make about a buffer, and let's now refer to it as thermal storage. If you have thermal storage, it is going to be the mechanism by which you access time of use tariffs. And that is the way we deliver what we call flexibility. So like charging your electric vehicle overnight. And that is how the UK PLC it's a significant part of how UK PLC is going to pay for the transition to low carbon heat. Okay, so there are other reasons for having a buffer. Keith, you've got a hand up.
Time of use tariffs means effectively, if you can be flexible by having that storage, you get cheaper electricity. Yeah.
Correct. So you charge the thermal store overnight and you bleed the energy into the house when electricity is expensive.
A bit like Economy 7 used to be. I wanted to just say,
Economy 7.
wanted to just give a few examples of things that I would encourage Whitby residents to look out for when you're having an assessment done. And a lot of them have been mentioned, but do make sure that you get the schedule of radiators sent to you, that you get the room by room heat loss sent to you. Look at it yourselves. If it looks like there's a mistake, you may be able to pick it up. It may be a bit easier than you realize. If you've got one room that's twice the size of the other, and you know that the number of windows is roughly the same, the wall type's the same, and the heat loss assessment is saying that the heat being lost from those rooms is identical, probably there's something that's gone a bit wrong there. So use your own intelligence, Google away. It's not, none of this is rocket science. Differences between a standard assessor and someone who goes the extra mile. If you get someone who's coming around with a thermal camera, or who is, with your permission, drilling a small hole in your cavity and sticking a bore scope in to check that the cavity wall insulation is actually as the energy performance certificate describes it, these are good signs. If you get someone who pokes his or her head into the loft and checks that the loft insulation is what it says on the energy performance certificate, rather than just checking it as a given, again, these are good signs. I'm not sure that they're fundamentally within the MCS guidelines. Certainly not drilling a hole in your wall.
We don't ask people go that far, Peter. No, it's drilling holes in walls, but we do ask that a heat loss calculation is done in accordance with BS 12831, which is the British standard for central heating design within the UK. Well, in fact, it's a European standard as well now. So your heat loss calculations should comply with a given standard, and they should be done to the required requirements for the property. But yeah, sorry, didn't mean to interrupt, Peter. Carry on.
Yeah, but there is. I mean, I kind of straddle both sides of this discussion, because I've worked in insulation and I've worked in heat pumps.
Yeah.
And I've seen an awful lot of cavity wall insulation which has either been badly installed in the first place. Yeah. And this included the last house that I owned, where basically it looked more like spider's webs. And perhaps it's been installed okay, but it's slumped. And these are the differences between a bog standard assessment, which I think that you will get from most companies, and a really top-notch installer who at the minimum will have, and this isn't a huge cost, that you can get a thermal imaging camera on your, as part of your mobile phone for, I was looking earlier in response to someone's question on LinkedIn, you can get that, you get an attachment certainly for £180. This isn't for you, it's for the professionals. Or you can buy a mobile phone thermal camera for 250. And I was alerted to this on a heat pump group because the co-founder of Kenza Heat Pumps uses one of these. To give him his name, Guy Cashmore. And they use that on their jobs.
Is it a Blackview phone?
It is, yeah.
Yeah, I know of them. Yeah.
And they have a better one when they need it for things which may end up in court, which has got a calibration certificate. But that one costs £30,000, whereas the mobile phone one was a very good job they found for £300 or less. So there's differences between heat pump installers. I fully recognise you're going to have a fight on your hands to get a choice, but you're doing a pretty good job of fighting.
And going back to what Richard said earlier, I don't think BG are going to put their name to a duff system, are they? You know, they're going to be offering all the guarantees and all the warranties that they should be, and they will be doing the calculations and the designs in accordance with the required standards.
Yeah, absolutely.
That's the whole point of it. Keith, you've got your hand up there. You've had your hand up for a while. Apologies.
That's okay. It's a question for you, actually, Julian.
Okay, I'll do my best.
Good. As part of the designs you do,
yep,
do you generally include zoned heating systems as well? Reason for the question.
Yep.
My heating system at the moment, when it's on upstairs, I've got 3 stories with the loft conversion, so I've got 3 stories being heated all the time. I've got my heating on.
Yeah.
Me, ideally, the bedrooms don't come on until later on in the day or the evening.
Yeah.
And then are heated away, which I understand is a zoned heating system.
It's a zoned heating system, and a zoned heating system is a requirement of building regulations where a property has a living area of more than 150 square metres. It may be necessary, but you don't have to zone heating systems on retrofits. That's for new builds and change of use and such as that. Zoning is a thing. You may benefit from it, but it can be quite disruptive to achieve in a retrofit situation, but not necessary for a heat pump. And also, sometimes heat pumps don't quite get on very well with zoning if you reduce the amount of water that's flowing around the system. So it can be beneficial, sometimes not. It's all on a case-by-case basis, and without coming to your house, doing a full survey, I couldn't tell you what you need exactly. Do you see where I'm coming from?
No, that's fine. That's fine, yeah. Julie. But when you come, just let me know which beer you drink, and I'll get a slab.
Yeah. Okay. Yeah.
Jonathan's also got his hand up, and I believe has for a while.
Jonathan. Yeah, I can see him in the chat.
Yeah. No response?
His mic's off. No.
He was the gentleman asking about buffers, so that might be a.
Right. Yeah.
That might be a legacy hand, as we now call them.
Yeah. Yeah. Absolutely.
So, I mean, again, in the interest of time, I'll be curious to know: is there any remaining questions that we've not addressed in? Oh, Paul and Sharon. Oh, hello, Paul.
Hello.
You're on mute, Paul.
You're on mute,
You're
Paul.
on mute.
Sorry, yeah. You probably won't be able to answer this, but it's come up and it's been said by the engineers when they were in yesterday. Oh, if you all go heat pump, it's gonna knacker the grid. You know, they're gonna be able to gonna have to upgrade the grid, and that's a problem for. So it's just I don't. Unless you know the supply around here, you wouldn't necessarily be able to answer that. But is that a big issue?
No.
I can give you a general response. You're quite right. I don't know the grid. We don't know the grid in your particular area. But this is a well-known, I'll say issue. It's not, I wouldn't consider it an issue. This is a well-known aspect of the transition to an all-electric setup.
Yeah.
And of course, it applies principally to electric vehicles. Mm-hmm. So making provision for heat pumps, whilst also making provision for electric vehicles, given that we know we've got a ban on the sale of internal combustion engines in 2030, this is why the flexibility is so important. This having cylinders and being able to shift your operation of your heat pumps and the charging of your cars around, because it reduces, every time we do that, we reduce the size of the cables we need to run in the ground, and we reduce the number of wind turbines and what have you that we need to deploy in the North Sea. So it's a massive part of the cost equation. Now, to give you some reassurance, the distribution network operators, the DNOs, so Scottish Power, Western Power, Electricity North West, they operate their investment cycles in 5-year cycles. We are currently about to come to the end of ED1, so cycle 1. April next year, cycle 2 starts. It's a 5-year cycle. Between them all, they're proposing, we're waiting for Ofgem to finalise the licensing, they're proposing to invest £28 billion in improving the networks. My firm expectation is that in 2028, ED3, that number will have gone up by orders of magnitude. So there is a constant move to improve the grid. Under the future energy scenarios, which is the document that the National Grid releases every year on projecting what's going forward, there is a level of confidence that the network operators and the generators will be able to keep up with demand, given that we are progressively increasing the demand. We're not doing it all overnight. So you're quite right. There are some areas where we have constraints at the moment. There's a well-known constraint on the west of London, for example, partly driven by 2 big data centres, I'm told. But so there are some constraints, but by and large, I am confident that the grid will keep up with the rate of deployment. Where you're doing a lot of deployment intensively in a limited area, such as could be the case in Whitby, clearly the network operator will need to have a good look at that. Okay, but I'm reasonably confident that this is not going to be a breaker. For most homes, you could put a 7 kilowatt EV charger and a 10 kilowatt heat pump on a 100 amp single phase supply.
And a slightly mischievous approach to that would be if everyone in Whitby said we want a heat pump, not a hydrogen boiler, you'll get yourself an upgraded grid, and you'll properly future-proof yourself in the process to have EVs and deal with electrification in general. The trial is offering you the alternative of a heat pump. If a significant number of you take them up on it, which would be our very strong suggestion, then if there are grid issues, then by the terms of reference of the trial, they'll need to sort that out for you. So that'd be a win-win.
It could be a win-win, but if we also want a heat pump, it won't go ahead.
Well,
because it's about piloting the infrastructure.
Absolutely.
Paul, I was talking to Mark Clark some time ago, who's the Cadent project manager, and he told me in that conversation that if more than 20% of residents go for a heat pump, they know the grid can't take it.
Yeah.
So let's just blow them out the water.
Yeah.
Well, I really want a free heat pump.
I would be getting that information direct from the distribution network operator, not from Cadent.
Absolutely.
So I would pose that question to. Are you Electricity Northwest up there?
No, we're Scottish Power, and I'm actually in conversation with one of their ops managers about something entirely different.
Yeah.
So next time we talk to him, I'll pick his brains a bit.
Talk to Scottish Power and get their view, because Keith Anderson, who runs Scottish Power, is on record for saying, electrify the hell out of everything. And I quote directly. So Scottish Power, absolutely electrify the hell out of everything.
Scottish Power are one of the good ones in all of this, as far as I'm concerned anyway. It's difficult to see how anyone could know that 20% would overload the grid. It depends on the type of heat pump. It depends on the size of the heat pump. There's all sorts of variables that sounds like a very random comment that you've had. I disagree. Also, just to chuck in here, it's all very well this talk about overloading the grid, but how do we feel about having 6 times more wind turbines and a hell of a lot more electric transmission cables to support green hydrogen?
Yeah, but that's not what we're talking about. We're talking about the impacts on the people of Whitby. Now, the grid in Whitby is collapsing at the moment. We have cables blowing out everywhere because it is so old. There are so many problems with the grid, which is part of the reasons I'm having the conversation with this ops manager anyway. And when we start to throw all the additional electric appliances at this, not just heat pumps, but cooking, fires and everything else, it's not something that should stop us from going the electric route if we want to. No, I'm just pointing out that there is something going on there that can it be fixed in time by Scottish Power, or does it mean the trial disappears up its own jacksie? We don't know.
And I think, again, just to get back to to focus in on the options for the trial and this whole notion of an informed choice. I mean, I think, I mean, we addressed the hydrogen issue at the last meeting, and I appreciate, I mean, it would be worth finding out the truth or not of that 20% go for heat pumps, the whole thing falls over. That could actually be a convenient way for Cadent to say, actually, we don't want to do it anymore because it's not viable for us and it's going to cost them too much money. But what I want to make sure is that we have given you enough information to make that informed choice around whether a heat pump is a viable option. There's bound to be some bigger issues around how the trial might be set up, what they do or don't want to give you, is the grid suitable. But from my perspective, my role here tonight is to have given you enough information, and Bean and Julian, to give you enough information, because that whole notion of informed choice is such a loaded phrase. And you know, whether whichever way you go, whether the trial ends up going ahead or not, you know, it's, do you have that information to think, okay, I know where I stand here now, I'm going to go that way. And that's what I want to leave this call, knowing with some degree of confidence that that's how you feel about what we've done tonight. So if that is the case, then I'm pretty happy with the evening.
Yeah, from a personal basis, Richard, yes, you have. I was tending that way anyway. I had a few concerns which you've clarified and sorted out. So yeah, and to be honest, I hope we do, as Beans just said, make the CEO of Scottish Power eat his words.
Right. Well, unfortunately, I'm gonna have to leave now. But what I want to say is I am on your Facebook page. Kate's got my email address. So if you have any more questions, please get in contact. I'm going to be actually up your way next week, so I may be dropping in on Thursday, time permitting. And yeah, please use that MCS certified email address for any questions with a Whitby Village in the title, and we can triage those to Julian, who'll answer them promptly-ish.
If I'm not out looking at heat pumps, Richard, but yeah, I'll do my best. Yeah. There's not just me, there are other people as well, but yeah, absolutely. We'll do our best. We'll send them all to Bean, just forward them all to Bean.
Can I just say then, thank you to the contributors. It's been a very informative evening. You might not think or like to be called experts, but in our eyes, I'm pretty sure we see you as the experts. Definitely. And it's been a really productive evening as far as I'm concerned. So thank you very much for your time.
Oh, you're welcome.
Thank you for that, Paul.
Yeah, and I'm sorry, but I'm going to have to drop out. So feel free. But thank you for that, Paul. And again, you're more than welcome, because you're having some stuff done to you rather than with you that it just shouldn't be. It's not right fundamentally.
Yeah.
Thank you, guys. Much
I'll
appreciated.
give you a shout in the morning, Richard. Yeah.
All right, Julian. Good stuff. Thanks.
Just before, thank you, everybody. Just before everyone just drops off, it looks like Bean's got one more thing to say. And this has been all about heat pumps. There is a much bigger version of a heat pump, which may be an option, which is not for tonight, but that might use some of the waste heat from the refinery and other stuff, and even smaller stuff like Morrison's. I think Richard may view that as a distraction. Certainly that's been some of the email correspondence. I'm not of that opinion. Certainly I think it's worth investigating. That's all I'm going to say about that now. Bean, did you want to say something? And maybe you could also explain why you've got a body warmer and gloves on. Is your heat pump packed up or what?
I'm going to have to leave now. Thank you all very much.
That is actually what I was going to address. But look, the question about district heating, yes, potentially should be thought about. But look, just because someone put up a post about it, yeah, I'm in a. This is actually a Montgomery made for the Navy. These were during the war. And yes, I've got a fleece on as well. And yes, I've got fingerless mittens on. My office is in a converted stable block, so I'm in 2 loose boxes. It doesn't have a heat pump. It's got direct electric heating. I run it very low. But fundamentally, I do believe in fabric first, and that includes insulating the people. And so I dress for the season. My kids, when they were younger, wanted to run around in the middle of winter in shorts and a t-shirt and drive the central heating. I'm saying, no, dress for the season, and I'll put the heating on when we need the heating on. So this is me eating my own, taking my own medicine, insulate the people, use the heat less. My office is currently 12 degrees in here, which keeps my brain cool. So what's left of it works reasonably well. But my body's warm. I've also, if you went down to the bottom, you see I've got New Zealand Uggs on as well. So insulate the people.
Thank you, Bean. I knew it wasn't going to be the heat pump there. I've seen you in that sort of gear long enough, often enough. Anything else before we call it an evening? Oh, there is. I wanted to ask you about whether you were familiar with the heat pump that outputs hot dogs and cold beer.
It's a new one on me, that is. Yeah.
Do you know what that one is? It's a Thomas Nowak one.
Okay. Thomas comes up with all sorts of weird and wonderful things.
No, this has actually been demonstrated, and Dave Pearson, I think, was there as well. So I think you basically had to have, I think the ratio was for every hot dog, it produced 4 cold beers. I think that was the ratio that was described to me.
But who wants their beer cold anyway? Beer should be cellar temperature. You don't want cold beer in it. Beer should be cellar temperature, not cold.
If you want hot dogs, you need a cold beer. This is just an example of how a heat pump works. It's moving heat from one place to another. It just doesn't waste stuff. It's a clever little thing. Anyway, on that point, that's enough for me.
Good night, everybody.
Thank you, Peter.
Good night.
Thank you for having us.
God bless.
Thank you for inviting us into your homes and into your discussion.
Thanks again.
Thanks, everybody. Bye.
Bye-bye.